Electrostatic precipitator Part 2. Construction and working of ESP. ESPs are common installations on coal-fired power plants. Electrostatic precipitator components. The attached figure shows electrostatic precipitator components. Here we are having a bigger diagram for your reference showing the various components of electrostatic precipitators. Here we are having the list of components which have been shown in the previous diagram. Request: it is hoped that this session is going to be useful to you. Please press like. Please subscribe. Once the particles are collected on the plates, they must be removed from the plates without re-entraining them into the gas stream. This is usually accomplished by knocking them loose from the plates, allowing the collected layer of particles to slide down into a hopper from which they are evacuated. Some precipitators remove the particles by intermittent or continuous washing with water. Plate wire precipitators. Plate wire electrostatic precipitators are used in a wide variety of industrial applications, including coal-fired boilers, cement kilns, solid waste incinerators, paper mill recovery boilers, petroleum refining catalytic cracking units, sinter plants, basic oxygen furnaces, open hearth furnaces, electric arc furnaces, coke oven batteries, and glass furnaces. In a plate wire ESP, gas flows between parallel plates of sheet metal and high voltage electrodes. These electrodes are long wires weighted and hanging between the plates or are supported there by mast-like structures, rigid frames. Within each flow path, gas flow must pass each wire in sequence as flows through the unit. The plate wire ESP allows many flow lanes to operate in parallel, and each lane can be quite tall. As a result, this type of precipitator is well suited for handling large volumes of gas. The need for wrapping the plates to dislodge the collected material has caused the plate to be divided into sections, often 3 or 4 in series with one another, which can be wrapped independently. The power supplies are often sectionalized in the same way to obtain higher operating voltages and further electrical sectionalization may be used for increased reliability. Dust also deposits on the discharge electrode wires and must be periodically removed similarly to the collector plate. Power supplies for the ESP. The power supplies for the ESP convert the industrial AC voltage 220 to 480 volt to pulsating DC voltage in the range of 20,000 to 100,000 volt as needed. The supply consists of a step-up transformer, high voltage rectifiers, and sometimes filter capacitors. The unit may supply either half-wave or full-wave rectified DC voltage. There are auxiliary components and controls to allow the voltage to be adjusted to the highest level possible without excessive sparking and to protect the supply and electrodes in the event a heavy arc or short circuit occurs. Working principle of electrostatic precipitator. This diagram shows the working principle. The voltage applied to the electrodes causes the air between the electrodes to break down electrically in action known as a corona. The electrodes usually are given a negative polarity because a negative corona supports a higher voltage than a positive corona before sparking occurs. The ions generated in the corona follow electric field lines from the wires to the collecting plates. Therefore, each wire establishes a charging zone through which the particles must pass. Particles passing through the charging zone intercept some of the ions which become attached. Small aerosol particles less than 1 micrometer diameter can absorb tens of ions before their total charge becomes large enough to repel further ions, and large particles greater than 10 micrometer diameter can absorb tens of thousands. The electrical forces are therefore much stronger on the large particles. As the particles pass each successive wire, they are driven closer and closer to the collecting walls. The turbulence in the gas, however, tends to keep them uniformly mixed with the gas. The collection process is therefore a competition between the electrical and dispersive forces. Eventually, the particles approach close enough to the walls so that the turbulence drops to low levels and the particles are collected. If the collected particles could be dislodged into the hopper without losses, the ESP would be extremely efficient. The wrapping that dislodges the accumulated layer also projects some of the particles, typically 12% for coal fly ash, back into the gas stream. These re-entrained particles are then processed again by later sections, but the particles re-entrained in the last section of the ESP have no chance to be recaptured and so escape the unit. Request: it is hoped that this session was useful to you. Please press like. Please subscribe.